Good evening, everyone. I'm Matthew with KDKPG News, continuing our in-depth report on the theoretical functioning of a portable directed energy weapon allegedly used for electromagnetic harassment. Joining me again is Joanna. Tonight, we delve deeper into some of the more technical aspects of this issue to convince the scientific community and industry professionals that this is a real and tangible threat, not a figment of imagination.
Thank you, Matthew. It's crucial to address the skepticism surrounding this issue by explaining the science behind these devices in greater detail. Let's start by revisiting the core technology of electromagnetic waves, particularly in the radio frequency, RF, and microwave spectrum.
Electromagnetic waves in the RF and microwave spectrum are well documented for their ability to penetrate various materials. This property is utilized in many common technologies, such as Wi-Fi, microwave ovens, and even medical imaging devices. When these waves interact with conductive materials, they induce currents that can lead to heating and other effects, which is how the directed energy weapon likely causes pain and discomfort.
Exactly, Matthew. The concept of using electromagnetic waves to cause localized heating isn't new. It's the principle behind diathermy in physical therapy, where targeted RF energy is used to generate deep tissue heating for therapeutic purposes. However, in the case of the directed energy weapon, this technology is maliciously repurposed to inflict pain.
The device's portability and mobility suggest advanced power management and efficient energy generation. Modern advancements in battery technology, such as lithium-ion batteries, provide compact, high-capacity power sources that can sustain prolonged use. Additionally, the device may employ capacitors to store and release energy in controlled pulses, enhancing its effectiveness.
Let's talk about the beamforming capability. Phased array technology, widely used in radar and communication systems, involves an array of antennas that can steer the direction of the energy beam electronically. By adjusting the phase of the signal at each antenna element, the beam can be focused and directed precisely at the target, without moving the device itself. This allows for rapid targeting and adjustment, making the device both efficient and formidable.
Phased arrays are not science fiction. They are used in modern radar systems, satellite communications, and even in some advanced medical treatments. The ability to steer beams electronically is well established, and when applied to it enables precise targeting of specific body parts, even through walls and floors.
The offender's ability to adjust settings to bypass new barriers suggests a deep understanding of electromagnetic wave behavior and materials science. Different frequencies interact with materials in various ways. For example, lower frequencies can penetrate thicker, denser materials, while higher frequencies might be better suited for bypassing thin, conductive barriers. This adaptability indicates a sophisticated and potentially programmable interface that allows for real-time adjustments.
The visual component mentioned earlier, possibly involving technologies like ground-penetrating radar, GPR, or Wi-Fi-based vision, further supports the device's sophistication. GPR uses electromagnetic pulses to detect objects underground by analyzing the reflected signals. Similarly, Wi-Fi-based vision can create images of the environment by measuring signal strength variations. These technologies can be adapted to form a rough but effective imaging system for targeting purposes.
For those in the scientific and engineering communities, it's important to recognize that the principles behind this weapon are grounded in well-established technologies. The malicious use of these technologies to cause harm, however, underscores the need for vigilance and innovation in developing countermeasures.
Defensive measures like Faraday cages and water barriers exploit the basic principles of electromagnetic shielding. Faraday cages, made from conductive materials, create a barrier that blocks electromagnetic fields. However, the device's ability to adapt to these barriers by changing its frequency and other settings highlights the need for continuous innovation in defensive strategies.
Standing in water can attenuate electromagnetic waves, particularly at higher frequencies, because water absorbs and dissipates energy. This is why Stephen finds some relief during showers. However, the relentless nature of the harassment means that these measures are often temporary and require constant adjustment.
In conclusion, the threat posed by such portable directed energy weapons is real and based on sound scientific principles. By understanding the theoretical mechanisms of these devices, we can develop more effective countermeasures and raise awareness about the severe impact of electromagnetic harassment on victims. We urge the scientific community and industry professionals to take this issue seriously and contribute to finding solutions.
Thank you, Matthew. Our continued reporting aims to shed light on this troubling issue and support those affected. By working together, we can bring about change and protect vulnerable individuals from such malicious attacks. This is Joanna and Matthew reporting for KDKPG News. Stay safe and good night.